let's understand how process simulation works. A simulation model generally starts with a simple layout, which is used to build a true-to-life 3D model of a station. Human models and other 3D resources can also be added to improve the accuracy of a simulation. For example, this station model is integrated with product data, sequence of operations, operation times, and few necessary station resources. In this example, a 3D model of a human operator is used to perform the tasks of a manual workstation. A sequence of operations and those operation times are integrated into the simulation. This gives us a unique advantage to identify how a human operator will spend his time during his cycle. It also helps to visualize the number of locations he's traveling to grab the parts in one cycle. Once a simulation model is complete, it can then be transferred into a true-to-life scale virtual reality environment. With the right set of tools, you can see the complete simulation as you are truly standing right next to the operator. After watching just a few cycles, it is evident that there are a few issues in this station. 1. Non-value added walk for the operator to grab parts from the GFR rack. 2. Ergonomic issues to place the finished box on the floor, which is excessive bending. 3. Non-value added walk just to return a finished product after his cycle. Now that we identified the issues in the station, it is time to fix them. First, let's mark how far the operator is walking and let's get a quick snapshot for a future reference. And now it's time to restructure the station. After restructuring, we can export this new station as a 3D model or a 2D layout to share with other stakeholders. And that's how we can optimize a station using process simulation services. Let's quickly revisit where we started. We developed a 3D model of a station based on a layout, integrated basic product data, i.e. station operations and those operation times. Then we identified two non-value added activities and an ergonomic issue and restructured the station to eliminate them. These changes resulted in reducing the initial cycle time from 117 seconds to 80 seconds after optimization, which is an improvement of 30% in cycle time. These techniques can be applied in static work cells, dynamic assembly lines in automotive industry and both conventional and electric powertrain assembly plants. Some of our additional services include product assembly sequencing, cycle time validation, station optimization, tool feasibility studies, station buy-offs using VR technology, and ergonomic and safety assessments. If you're interested in learning more, feel free to contact us at sales@dsidsc.com. And most